So my next speaker is also a Mr. Lee, Hongsuk Lee from Neurocle. And he's talking about auto deep learning algorithm in machine vision applications with Neuro-T. So, Mr. Lee, the floor is yours.
Hello, everyone. I'm Hongsuk Lee from Neurocle. And today, I'm going to talk about the auto deep learning algorithm in machine vision applications. So, it doesn't work. OK. Yep. So let's talk about the how the vision inspection has been developed. So, of course, from the manual inspection to rule-based algorithm, there are a lot of the improvement. And also, for 5 years, from rule-based algorithm to deep learning algorithm, there are also some improvement as well. However, still, there are many pain points to apply the deep learning in the real applications. So I'm going to talk about 3 things, the pain point of the current deep learning algorithm right now. So first challenging is actually requires skilled deep learning researchers or engineers. So as you know, when we train the deep learning models, actually we have to find out and we have to optimize the deep learning architectures or the hyperparameters based on the training data. But however, normally our customers, like system integrators or OEM or even end users, they don't have much deep learning engineers inside. So it's very hard for them to optimize all the architectures or hyperparameters. So then they have to train and they get their model. But however, the models are not satisfied for them. They have to retraining again. This is actually the reality right now near us. So there are so many difficulties on customizing model architecture and hyperparameters. That is the first challenging right now. And the second challenge is that we require high-end hardware, such as GPUs. So of course, we can use cloud or we can use GPU PCs. But in some specific environment, we cannot utilize a normal PC with GPU, or even we cannot put in the PCs. So in that case, we have some limitation on the capability to various environment. So the second thing is, we also require some additional process to update the deep learning models. So firstly, just assume that we create the best performing models and go into the real production lines. But however, as time goes by, a month ago or 2 months later, oh, there are some changes on the product, or there are some changes on the lighting. So in that case, actually, deep learning is example-based learning. So we have to retraining based on the latest data. But however, it also consumes a lot of the resources and cost as well for the frequent retrainings. So I just say 3 big challenges right now by using the current deep learning algorithm. So I think we have to move on from normal deep learning algorithm to so-called auto deep learning algorithm, a technology that can easily and quickly create the optimized deep learning models without any help of the experts. So our company, Neurocle, provides 2 software, Neuro-T and Neurala, which are the auto deep learning vision software. That is the GUI-based deep learning vision software for image analysis. So our Neuro-T and Neurala software, it solves the 3 biggest challenges which the current deep learning algorithm has. So I'm going to talk about 3 things on the model training part, and model deployment part, and the maintenance part as well. So firstly, model training part. So as I mentioned, there are so many retraining to find the best performing deep learning models. So our Neuro-T software actually provides auto deep learning algorithm which optimize the model architectures of the deep learning, and also data augmentation setting as well, and also the hyperparameter optimization. So even non-expert, they can, of course, they have to upload all the images and they can do the labelings to input the ground truth. But however, they don't have to think about oh, what kind of model we should take, or how I can get the data augmentation based on my training data. Or oh, there are so many hyperparameters, there are at least 20 hyperparameters for deep learning training. Then there are so many cases for the hyperparameter settings. So I don't know how to set up these hyperparameters, but they don't have to think about it. Our Neuro-T software will automatically optimize all these things so that they just input the training data and then do the labeling. Then they just click the training. Then we are going to provide the best performing deep learning model by once. And also, let's think about some model deployment as well. As I mentioned, in some specific environment, we cannot use even PCs. Then actually, we can think about some like embedded board, such as like Jetson. So in that case, however, compared to the Jetson or normal PC, the Jetson's processing power is much, much lower, actually. So in this case, we have to create the lightweighted model. So try to apply deep learning technology to diverse industry and diverse environment. We also have a function to create the lightweighted model for the embedded environment, so that we can apply deep learning models on the normal PC, normal GPU, or CPU, and even on the embedded board, so that there is like no limitation on the environment. So that like even we can make some hand-carry devices with deep learning as well. So lastly, let's talk about the maintenance parts. So as I mentioned, like due to the like technology itself, deep learning is a learning-based, example-based algorithm. So definitely, I can say retraining is also very important in the realistic case. So in that case, then we can think about how we can retraining. So firstly, of course, we can just do the general retraining, which is like there are like, for example, like 100 data initially, and then we add up some 50 new data. Then we can train with 150 data. That is, I can say, like general retraining. Of course, this is good because we are going to use all the data from the initial stage. But however, the training time will be longer compared to the other methodology. In that case, many people are these days talking about the transfer learning. Transfer learning is actually starts from the initial model, and then we are going to add up the new images and do training. But however, in this case, of course, the good thing is the training time is shorter. However, we are going to freeze the first model and then add up the new images and training so that the model weight balance is not really balanced. The weight a little bit not balanced, so it can be more overfitted on the new images, or it can be overfitted on the previous images. So these are another some limitation of the transfer learnings. So we also develop our own like fast retraining methodology to use the whole data with a short time based on our auto deep learning algorithm. So make it easy to maintain and recreate the models. So it's very easy to maintain on the real manufacturing sites. So I'm going to talk about like 2 examples lastly. The first example is the industrial film cases. In this case, actually, we have like 5 different defects, such as like bug, dots, scratch. So by using some old way means actually the normal deep learning architectures and training, like the accuracy was around like the 90%. But however, by using our auto deep learning algorithm, which optimize architectures and hyperparameters, it can go up to around like 99% without any help of the experts of the deep learning. So these are the models created by the non-experts. And this is another case actually from the logistics. You know, on the logistics, we are using a lot of like the plastic pallets, as you can see. But however, there are so many like pallets, actually, the red pallets, or the green pallets, or the black pallets. So in that case, actually, the very important thing is the maintaining the model. So by using the previous method for the retraining, actually, our logistics center only maintaining like 4 different products by using deep learning. But however, by using our auto deep learning and fast retraining function, they can go up to like around like 10 times more, like 40 products to create the deep learning models on the real logistics centers. So these are the 2 examples we have done before. So let me summarize. So you can get the like auto deep learning algorithm advantage with the Neuro-T of the fast deployment and low device dependency and the easy maintenance. So that's it for my presentation. So if you are interested, then you can visit our booth at the Hall B, B13. Thank you very much.